Hello, linear algebra student. This video is for chapter 1.7, part 3. So wrapping up the last example that we did. So to check, we have three vectors with an unknown h, and we try to figure out what value of h would make this a dependent set. So we set up an equation of x1, v1. This is v1, v2, v3, right? And try to solve it equal to 0, 0. And because there's an h here, so we have to use hand calculation to do the row echelon form, just row echelon form to find the prefix column. And we notice that we have two prefix position after we finish making it into a row echelon form, and one free variable, which is x3. So and x3 is, so no matter what h is, it could be any number. This does not prevent these to be a valid solution. So you always have a free prefix column, a free variable. So non-trivial solution must always exist for all value of h. So this shows that. And then for that to happen, you really to show, you can say, yeah, you can solve for it. Okay, example 3. Maybe I'll talk about it during class on how to actually prove it by definitions. How many prefix column must a 4 times 7 matrix have? So according to theorem 8, which is the size of column and size of columns and size of rows. If you have 4 rows and you have 7 columns, 4 times 7 means you have 4 rows, right? So it's like 2, 3, 4, and then you have, 1, 2, 3, 4. So you have 7 vectors, but only 4 rows. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, right? And then you are to think of 0, 0, 0. So if you do a row echelon form, the maximum of free variables that you the maximum of prefix column that you have is actually 4. So you must have some free variable, and so it must be dependent because 4 is less than 7. Okay. And how many prefix column must you have? If you have a 7 times matrix for it to be linear independent. So if I have the other way around, I have a lot of 1, 2, 3, 4, 5, 6, 7. I have a lot of entries, but each one of them I have 4 vectors. 1, 2, 3, 4. So each one is 7 entries, right? 2, 3, 1, 2, 3, 4, and also another 7. 1, 2, 3, 1, 2, 3, 4. So we want to know how can this be linear independence? For it to be linear independence, it has to have only the trivial solution. So that means you must have 4 columns, 4 prefix column. So it has to be, should be like this, any, so that there's no free columns to avoid free variable. And if that is the case, the only way you can solve them would be equal to 0, right? So if this is the only trivial solution, then when you solve it, so then you would be independent. So that would be independent. Independent means the only way you can make them to be 0 is 0. Okay, so that's all for this 1.7.